Hello, in this video we're going to be taking a look at cross sections and how they affect the volume and surface area of our objects. So a cross section is a two-dimensional figure formed by the intersection of a solid object and a plane. So here we have a cylinder that has this cross section that's going through it. So this thing right here is the plane that is intersecting our cylinder. And that cross section creates this shape right here. This cross section, that two-dimensional figure, in this case would be a rectangle. It doesn't quite look like a rectangle. It looks kind of a little tilty because they're trying to make sense with that 3D shape. But the idea is that it should have the same lengths here and here, as well as the same lengths here and here, making it a rectangle because it's going to go through the same parts of our circle, and the height is the same all the way around our cylinder. Now this shape isn't quite a polyhedron because it's kind of got that hole in the middle, but it's like a donut bagel shape. But we can make a cross section by cutting that bagel in half, which creates cross sections that are both like circles. So this is like two nested circles. We get a better thing from a proper polyhedron over here. So an orange is a sphere. But when we create a cross section of that sphere, we learn a little bit more about the shape, and our cross section here is the circle. So the idea of these is cutting a two-dimensional figure out of these three-dimensional shapes, which can be important when you're looking at a mixture of different polyhedron and trying to find its volume or surface area. So let's check that out. So I've got a composite solid object here, and I want to figure out its surface area and its volume. When I'm going after the surface area and volume of this thing, I might want to try to figure out, okay, what is sort of like my total equals parts for this shape. But I've got to be careful about overlaps between these different parts. When I look at this shape, what I see in the middle is a prism that goes through this thing right here. So this makes a prism in the middle of this shape, and then the outside makes a cylinder. So I've got the parts, which are a prism plus a cylinder. Now, when I find the volume of this thing, that's not going to cause any trouble because I'm just trying to figure out, hey, what's the volume of the prism plus the volume of the cylinder? No issues. However, when I find the surface area, I'm going to run into a little bit more trouble. So I want to take care of the volume first because that is going to be the easy part. So if I did the volume of this thing, so the volume of my prism is going to be the area of the base times whatever the height is, and then the volume for my cylinder, like the two bits that are on the outside, if I smush them together, they are going to make a nice cylinder, is the height of our cylinder times pi r squared. So let's just fill in those bits of information and we should find our volume. So the base of area of the base of this thing is 6 by 4. So 6 times 4. And then the height of that thing is going to be 3. Now, fortunately, the height for this thing is going to be the same as the height of the prism, as well as the height for our cylinder. So we can use this as the height for both of those things. Neato. So there we go. I still need the radius of this cylinder on the outside. Remember, I'm using the two pieces to make a cylinder. Now, this 4m is the diameter of that circle that's on the top and the bottom, but it is not the radius of that circle on the top and the bottom. To find that, I got to cut that in half. So my radius is going to equal 2. So this volume is going to be 6 times 4 times 3, which is 72, plus 3 times 4, 4 pi. It wants me to leave it in terms of pi, so I'm just going to leave those alone. Those aren't like terms, so I can't put them together. So 72 plus 4 pi meters cubed. Now, I said the surface area is going to cause us a little bit more trouble. When I go after the surface area of this thing, the cylinder is going to be remaining the same. I just need that cylinder, that outer part of that thing. So it'll just be whatever our surface area for a cylinder is. However, if I just do the surface area of a prism for this blue box in the middle, I would get too much. I would get this surface area of this shape that's inside of our object, and I don't want that. I just want the lateral area around the outside of that prism. So I just need the prism's lateral area. When looking at the surface area formula, the perimeter times height is giving me the lateral area of that shape. So that's really what I want to be looking for. Now be careful with that height. I can't use the regular height. I'm going to have to adjust that a little bit. So this lateral area is going to be the perimeter around here. So that is 3 plus 3 plus 4 plus 4. Times the height that goes in this direction, because I'm just taking this perimeter and multiplying it by the height that's going this way, in this case, this 6. So we'll use this as our h for that lateral area, which is not the same as the height of our prism that we used before. Then we just got to plug in the rest. So 2 pi, we'll need an r and h plus 2 pi r squared. Our r is going to be the same as when we found it before, so 2 and 2. And our height, this cylinder's height is not going to be changing. We're going to use the same 3 that we had before. So our surface area is going to be 14 times 6, which is 84, plus 2 times 2 is 4, times 3 is 12 pi. 2 squared is 4, times another 2 is going to be 8 pi. So that makes our surface area, we can put these two together because they're like terms, 84 plus 20 pi meters squared. So be careful about what sort of adjustments you need to make in that overlap of the prism and the cylinder, so you don't double count faces. Now that was a lot, so let's try it again. So in this example, again, I want to think about total equals parts. And I want to think about what are the parts that I'm dealing with here. I've got a prism on the bottom again. So this shape down here is a nice prism. But then on the top of that lunchbox is a cylinder, but it's not a full cylinder this time. This time we only got one side of it. So our parts seem to be a prism plus only half of a cylinder. So as we work with that cylinder, we want to make sure that we're always dividing it by 2 in terms of surface area and its volume. Let's start with volume again, because that was the easier one. So the volume of this thing is going to be the volume of the prism plus half of the volume of what a cylinder would be if we had that full thing. So our prism is base times height plus half of our cylinder formula. So we'll have to do half of our cylinder formula, which is h times pi r squared. Now, I think we're going to have different h's this time for the height of, no, I think it was the same h. Same h. Never mind. I'm sorry. So the height of this cylinder is this 10 right here. So let's use this as our h for both things. And then our base for the prism, let's have that base B be over here on this side. That way we can keep kind of that same height for both of our shapes. Fortunately, that 3 is a proper radius because it's going from the center of the circle to the edge. So this is our R. All right, so area of our base, this base right here, its area is 6 times 6. So I'm just going to write that in as 36. And then the height of our lunchbox is 10. So that's perpendicular to that base. And it's perpendicular to that nice half cylinder on top. So that's 10. And then we got a half times 10 times pi. And then our radius squared. In this case, our radius is 3. So we just need to simplify that down. 36 times 10, that's 360 plus, let's see, 5, and then 3 squared is 9, so 5 times 9 is 45 pi, and that's just going to be inches cubed for our volume. All right. So now, tricky one, surface area. Now, if we think about our cylinder, if we want to cut that in half, our half cylinder, that's still going to work. So we can just still do half of whatever our normal cylinder surface area would be. We should be fine. So it should be half of our 2 pi RH plus 2 pi r squared. Make sure you multiply all of that stuff by that 1/2. Now, the surface area of this prism, I think, is going to be a little bit trickier than before. We can't just do the lateral area of that prism. I think what would make more sense is if we found our regular surface area and then we just subtracted that top because there's this weird top up here that we don't want to include. So it should just be our regular prism area, and then we just subtract away our top. And then add it on to this mess. So that's 2 times the base plus perimeter times height minus our top, which is just going to be 6 times 10. Plus all that red stuff. So 1/2 2 pi RH plus 2 pi r squared. Okay. So 2 times the area of our base, that's 6 times 6. So that was 36 plus the perimeter of this thing. So going all the way around this thing. So that's 6 plus 6 plus 6 plus 6. And then the height, which before we said was 10. Minus our 6 times 10 plus our half 2 pi r h plus 2 pi r squared. So r we said was 3, and then our h we said was 10. Oh boy. So let's simplify that down. So surface area is 2 times 36, that's 72, plus 24 times 10, so that's 240, minus 6 times 10, that's 60, plus half of, let's see what we got here. 2 times 3 is 6, times 10 is 60, so that's 60 pi, plus, Mr. Parentheses down there, 9 times 2, that's 18 pi. All right, 72 plus 240 is 312, minus 60, plus half of, let's see, 60 pi plus 18 pi, that's 78 pi. That equals 312 minus 60 is 252, plus half of 78. 78 divided by 2 is 39. 39 pi inches squared. Oof. What a mess, but we're done. Working with these composite objects, make sure you're thinking about total equals parts, break it up into the parts, and then start plugging in those formulas. Note that I'm very much on purpose writing out what that formula is before I actually start plugging in those numbers. It makes it a lot easier for me to make sure that I'm keeping track of everything that I've got to do for these big messes of problems. Look for those cross sections. In this case, we had that cross section of a rectangle that cut through those composite shapes that we might need to remove in order to figure out that volume or surface area. Thanks for watching. Bye bye.